Hello and welcome to Algebra. Today we're going to be graphing exponential functions. In our first lesson from this, our first part of this lesson, we looked at linear versus exponential. Then we continued on and looked how to evaluate exponential. So now we're going to learn how to graph exponential functions. Now, there's some different basic types. When you have the opposite of an exponential function, you've got it's going to be beneath the y-axis. You see both of these, the opposite of 4 to the x, it's underneath, if you will, it's in quadrants 3 and 4. Same thing here. And then when you have just positive out in front, you can separate this into y equals a times b to the x. When a is negative, as in these two, then it's going to be beneath the y-axis. But when a is positive, as in these two, then it's going to be above the y-axis. Now another thing that you can look at is if b is greater than or less than 1. Now if it's greater than 1, what we're going to do is in these top two, it's going to start very, very close to the y-axis and then get very, very big or very, very small, depending on whether a is positive or negative. If b is less than 1, then it ends up very, very small as you go towards infinity. So once you get large values of x, then it's going to be very, very close to the y-axis. But to the left of the y-axis, it is either very, very it's either a very large number or a very, very small number. So it just kind of gives you an idea of some of the different possibilities that you'll see with these. One thing that's in common is that you'll always notice anything to the 0 power is 1 or negative 1, depending on whether it's in parentheses or not. So this 0, 1 or 0, negative 1 is going to happen for all of these exponential functions. Now that probably doesn't make sense until we actually do some problems. This is more of a slide to go back when you've seen this once, and it should sort of sum everything up. So we're going to graph this exponential function. I have to be very, very careful. We're going to use a table of values. The table of values is not a fantastic tool for one particular type of function. When we're graphing exponentials, you can use a table of values. Linear functions, use a table of values. When we're doing quadratic, cubic, any of these different kinds of functions, the table of values is going to be effective for all of them. So we're going to go ahead and look at this one. Now, I would stay centered around the origin with the x values. So I'm going to use -2, -1, 0, 1, and 2. And that's probably a good template to use for any of these exponential functions. And be very careful when you plug these in. So we're going to say y equals -4. And put this in parentheses. So plug in a -2. Be careful with this. Now, the -2 doesn't have authority over the negative. You might think it does, but not really. This is really in the form y equals -1 times 4 to the -2nd. So we're going to Chuck Norris this. Put over 1. This gets booted down to the bottom, so y equals -1 over 4 squared. So that's y equals -1/16. Now it's always a good idea, slow down, double check, and make sure, because there's a lot of opportunities for careless mistakes on this. So we plugged in the -2, separated this into -1 times, booted this down, 1 over 4 squared, 1/16. Yes, that is correct. It's kind of like using the dishes. As soon as you use the dishes, wash, use the dishes again. This time we're going to plug in a -1. Now don't make the common mistake. Some people will say, oh, -4 times -1 is +4. No, 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 no. Very different concept. This means the opposite on the number line. So +4 versus -4. This -1 is referring to there being a fraction, that it either needs to be in the numerator or in the denominator of a fraction. So we're going to separate this again. -1 times Chuck Norris. Because this is a negative exponent, boot it down. It's -1 over 4 to the 1st, or just -1/4. Plug in 0. Y equals the opposite of 4 to the 0. That is negative 1 times 4 to the 0. Negative 1. Anything to the 0 power is 1. The thing is, some people will say, oh, well, negative 4 to the 0, this is 1. Not necessarily. This 0 does not have authority over the negative and the 4. And if it's in parentheses, it does. If it's in parentheses, that would be positive 1. But since this is not in parentheses, the 0 has authority over the 4, but not over the negative. So 4 to the 0 is 1. This is negative 1. And now we get to, hopefully, a little bit easier numbers. Plug in a 1. Negative 4 to the first power is just negative 4. Negative 4 to the second power, that is negative 16. And again, this isn't in parentheses. That's not the way that's written. That is a different problem entirely when you put the parentheses there. Without the parentheses, if you had the parentheses, that would be positive 16 because there are two negatives. That 2 has authority over the negative as well as the 4. But in this case, we have the opposite of 4 squared, which is negative 16. And now we have enough data to graph. So negative 2, negative 1/16. When you're dealing with exponential functions, get used to having something that's very, very close to the x-axis. You're either going to have things that are very, very close, 1/16, 1/64, and closer and closer. Also, we're going to have some numbers very large or very small. Negative 1, negative 1/4, 0, negative 1, 1, negative 4, and 2, negative 16. And you notice this is getting away from that x-axis very, very quickly. It's getting away from it exponentially, and that's where that comes from. Now, as you go this way, it's going to get closer and closer and closer to that x-axis. So what I'm going to do is I'm going to put a dotted line here. What I'm saying is it's going to get very, very close to this line. How close? Infinitesimally close. Very, 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 very close. It's going to be so close that the human eye will not be able to see how close, which of course makes it very difficult to draw. You're going to have to do the best you can. This is going to become almost vertical. You're not going to be able to tell that it's not vertical, but it's become almost vertical, but it never quite is vertical. It looks like it is because it's going up so quickly. And that is the graph. Now this blue thing, if you'll remember from previous lessons, this is an x-axis, this is an x equals something, this is the y-axis, this is an y equals something. So this line is going to be a y equals something. Well, what does y equal? It equals 0. So there is a horizontal asymptote, kind of a funny spelling there, but a horizontal asymptote at y equals 0. What does that mean? That means as you go to negative infinity, you're going to get very, very close to the x-axis. It never crosses that line. Gets very close to it, never crosses that line. All right, let's look at a new one. This is the graph. So the basic idea is on these exponential functions, you're going to have a horizontal asymptote somewhere. That's just part of what makes it exponential. You're also going to have, the best way is to go through with a table of values, plug them in, see what happens, be very, very careful. Those careless mistakes are going to happen very often, unless you're careful. Just take it easy, take it slowly, be deliberate. All right, so we're going to go ahead. Now, this is positive, the base, and so you know that this is going to be above the y-axis. Also, this is bigger than 1, so you can think 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. These values are going to get very, very quickly past, excuse me, above the x-axis very quickly to the right of the y-axis. So in quadrant 1 here, this is going to be shooting straight up. And so that gives us an idea. It's going to come up here and then come down across. And that's going to be the basic idea. Now let's get the details. -2, -1, 0, 1, and 2. So that's a good little skeleton, a good outline to use here. Excuse me, y equals 1/10 times 2 to the -2nd power. Now this does not have authority over here, so this is 1/10, and I'm going to write out the fraction just because I prefer fractions. This is going to be a Chuck Norris situation, so boot him down. 1 over 2 to the 2nd. Y equals 1/10 times 1/4. That is y equals 1/40. Can you write out the decimal form? You can, but it needs to be precise. So don't round, don't truncate it. Just make sure that you have, if it is exactly the correct decimal form, then that's fine, but don't round it, don't truncate it. Alright, let's try y equals 1/10 times 2 to the -1st power. Again, I'm going to use the fraction equivalent here. Just gives me a little bit more precision. And this is going to be a Chuck Norris, boot them down. So 1 times 1 is 1, 10 times, of course 2 to the 1st is 2, 10 times 2 is 20. So that's 1/20. To the 0 power. One-tenth. Now this is not the opposite of 2 to the 0. That would be -1. This is just 2 to the 0. It's +1. So 1/10 times 1 is 1/10. Excuse me. Y equals 1/10 times 2 to the 1st power. Well, that's 1/10 times 2. I'm going to put 2 over 1, rationalize it, make it into a fraction. 1/10, let's see, 1 times 2 is 2, 10 times 1 is 10. That's going to be 1/5. Rewrite this, it's getting away from me a little bit. The more organized your work can be, then the less likely you are to make a careless mistake. Let's plug in 2. So 1/10, write that as a fraction again, times 2 squared is 4. I'm going to rationalize the 4. Y equals 4/10 or 2/5. Alright, so -2, 1/40, just barely above the x-axis there. -1, 1/20, again, just barely above the x-axis. 0, 1/10, still barely above the x-axis. Now you notice I had said earlier that you always have 0, -1, or 0, 1. Well, that's where a is 1. Notice there's nothing that's multiplied in front of these besides 1 or -1. Well, in this case, we had 1/10 multiplied. That's why we don't see 0, 1 as one of those points. 1, 1/5, 2, 2/5. Now, that looks like a line locally, just right around that area. So what I'm going to do is to get an idea of how this is going to curve further on, I'm going to go ahead and put in the point 10, and let's see what this is going to do. Basically what I'm doing is, just like a crime scene investigator, I'm going to look and say, okay, what happens over here? What happens over there? And investigate a little bit more, because I get the idea to the left, it's going to stay very, very close. 1/40, 1/80, it's going to keep getting very, very close. In fact, we could go ahead and say that the horizontal asymptote is going to be y equals 0 again. But we also know that this is going to be curving up. Well, how quickly is it curving? That's what I want to know. So let's plug in 10 and see what happens. Y equals 1/10 times 2 to the 10th. Well, 2 to the 10th power. Let's see, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 1024. So 1/10 times 1024. Divide that by 10 and you're going to get y equals 102 4/10. Now this looked linear. There's no way I can get to 102 4/10. That's way too high. Let's try something a little less, maybe 5. What I'm doing is I'm trying to find how to curve this. Y equals 1/10 times 2 to the 5th. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So y equals 1/10 times 32. Well, that's going to give me 32/10. Or you could say y equals 3 2/10 or 1/5. So 3 1/5. So that's something that I can use. 1, 2, 3, 4, 5. 1, 2, 3 1/5. And you notice this is starting to curve up nicely. It's going to be difficult to draw this. It's going to be kind of difficult to graph this, so I'm going to do 4 as well. Do I have to? No, but I'm trying to get more of a feel of where this is going. So 5 3 1/5. Let's see what 4 does. 1/10 times 2 to the 4th. 2, 4, 8, 16. So y equals 1/10 times 16. Put it over 1, that's 16/10, or y equals 8/5, or you could say 1 3/5. So when we get to 1, 2, 3, 4, 1 3/5, that gives me a nice curve so I can understand exactly where this is going. Again, it never becomes absolutely vertical. It gets close. It appears to be that way. Just like it appears that this is a straight line, it is getting closer progressively to 0. And there we go. That's how to graph exponential functions. When in doubt, put in a few more points and investigate. It just can't hurt to do that.